managers. So let's get started with the product statement. We are asked to build a model to predict the electrical energy output for a system. The table below that you see are there are four independent variables and five, and the fifth one is the dependent or the output variable. So let's head over to the raw table. So the one that you see on the shaded is the raw data that we were provided. Total of 9,500 entries approximately. Uh, and yeah, the shading, you might ask what is the shading. So there is purple shading for train data and test for test data is color coded with light pink or light red. That is a split of 80 is to 20. 80 training, 20 test. So as some of the basic observations that we see is all the variables here are continuous. So which gives us a hint that we should think about linear regression. And since there are more than one variable present, we can create a structure for multivariate linear regression. And like I said, we will split the data into 80 is to 80% as trained data and 20% as test data. So the output metrics that will compare across the two approaches that we have decided will be RMSE, MAE, MAPE, and R square value. So coming to the first approach, here it is nothing but a very simple multivariate linear regression model where we have considered all the four input variables, and then based on that, using the data analytics tool we have got in Excel, we have got we have got all the summary output that you see on the current page. The R square value is 0.93%, which signifies 93% of the variance in the outcome variable can be attributed to the predicted values. The highlighted portion that you see is the are the coefficients that the model has calculated and given to us. Again, the significant F score is 0, which is less than 0.05, and hence the data is statistically significant. Coming to the results, that is the coefficients that we have applied on the test data and what have we got the values as. So the first five columns are the test data, the remaining columns are calculated by us, predicted output, absolute and square of the absolute error, and absolute error percentage. So these are the four values. I mean, these are the values for the four metrics that we have got from approach one. Coming to approach two, in approach two we have done a slight change. What we have done is the variable with the least absolute coefficient value with the output variable, we have dropped that variable. So in this case, we have three input variables instead of four for calculating the output variable. So again, in this case, the R square value is 92, which is very good. And we have got the coefficients calculated by the model. So yeah, this is the output for the approach 2 that we have taken. Methodology remains the same, just one column is less in this approach. Coming to the conclusion, so like we said, we have two approaches for this, and you can see how the metrics are across these four variables. RMSC, you can see RMSC, MAE, and MAPE should be as low as possible, and that is lower for approach 1 compared to approach 2. R square value signifies how your model is fitting to the raw data. So that is the higher the better. So again, that is higher for approach 1 and approach 2. So the final conclusion that we arrive on is approach 1, where you have included all the variables, is a better model. Thank you so much.